Hello everyone. We need to talk about how we might optimize or maximize or minimize multivariable functions. So let's think back to the 3 steps that we used in order to maximize the profit. So the first thing was take the derivative, p prime. Second thing, set your derivative equal to 0. And then the third thing was solve for your variable. Right? With the minimizing the inventory cost, what did we do? We took the derivative, set the derivative equal to 0. You guys did this recently, so this should be familiar. And then the third thing was to solve for your variable, right? How do we maximize the revenue? You took your derivative of your revenue specifically. You set your derivative equal to 0, so your marginal revenue equals 0. So then 3 is solve for your variable. So that means that we should be doing the exact same things if we're going to take the derivative of a multivariable function. However, if you look closely, step 1 is to take the partial derivatives, plural. So you're taking derivatives, you're setting them equal to 0, and then 3 is to solve for your variables, plural, right? Your x and your y, z, whatever that might be. So I'm going to go through some problems that are directly from your notes. Okay, so right here, I'm going to walk you through that. And all we're going to do is find the possible max-mins. All right. So here we have f of x equals x squared plus y squared. So the f of x, y, I'll just rewrite it. X squared plus y squared minus 4x plus 6y minus 4. So here's step 1, take your partial with respect to x and take your partial with respect to y. You need both derivatives. So 2x minus 4, okay, f sub y, 0 plus 2y minus 0 plus 6, okay. So then step 2 is to set those derivatives equal to 0. So 2x minus 4 is equal to 0, and then 2y plus 6 is equal to 0. Now, if you only have an x in your function, in your equation, only an x, and this one has only a y, then this is pretty straightforward because all you're going to do is go off to the side and say 2x minus 4 equals 0 plus 4 plus 4. 2x equals 4, divide by 2, divide by 2. This yields x equals 2. Done. All right? So for this one, you get 2y plus 6 equals 0. So subtract 6, subtract 6. 2y equals negative 6, divide by 2, divide by negative 2. This yields that y equals 3. Okay? So what's your point? You have a 2 and a 3, and you also have a last coordinate, a z coordinate, so x, y, and then z. Okay, so the question is, how do you get the I've made an error. This should be positive here, right? So this should be negative 3, right? So this would be negative 3 here. Okay, so the question is, how do you get this last coordinate, x, y, and z? So the z part. So if you have both of your x and your y, you can finally go all the way back up to your original function. You just plug it in there, right? So this last coordinate is f of 2, negative 3, which says, hold on, let me see if I can zoom out so that you can see it. Okay, I'm going here, look where my finger is. 2 squared, right here, plus negative 3 squared minus 4 times 2 plus 6. Let me try to separate this some way. Times negative 3 minus 4. So that number is going to go here. All right, so I need to talk briefly to you about what a three-dimensional point looks like, and I'll do that in the next video.